Hi, welcome to the video solution for Edexcel IAL Physics. This is Edexcel IAL October 2020, Unit 4. This is the second video of this paper. So let's start. Question number 15. A student carried out an investigation to compare the energy stored in a mechanical mousetrap with the energy stored in an electronic mousetrap. The photograph shows the mechanical version trap before and after it is set to trap a mouse. This is before and this is after. The trap was set by applying a force on the lever at a point A. The lever rotated through an angle of 90 degrees, stretching a spring. The force was applied at right angles to the lever throughout the process. So you apply a force on the lever in this direction, F1, which is, and then you keep applying. Lever comes here from this position and the trap is set. The initial force was applied as 2.6 and increased steadily to final value of 9.6 when the trap was set. Show that the work done setting up the trap was 0.5 joule. We need to find work done. Remember, it's all about you are applying force and you are stretching a spring. That means energy is stored. Energy stored is stored, and this energy stored is equal to work done. So if you need to find the work, you need to find energy stored, and energy stored is E is equal to half of F delta X. And remember, this half of F in this formula, this half of F is basically average force, which is F1 plus F2 divided by 2, and delta X, which is in fact extension, but in this case delta X will be the distance, and this distance equal to the extension. This distance we can find distance covered by the lever, and this is the quarter of the circle. So this is delta X. So delta X is in fact quarter of the circle. So the full circle is 2 pi r. Quarter means divided by 4. So pi r divided by 2. So now you can find the work done, delta W, which is energy stored. So energy stored half of F. F is F1 plus F2. So 2.6 plus 9.6 into delta X. Pi r. R is the radius, and radius is the length of the lever. This is the radius R, which is the length. So 4.9 centimeter converted into meter. So 0.049 divided by 2. If you solve this, delta W or the work done or energy stored will be equal to 0.47 joule, which is about 0.5 joule. The electronic mousetrap works by applying a large potential difference across two metal plates. The diagram shows part of the circuit for the electronic mousetrap. The transformer T consists of two coils wound around a single iron core. An alternating potential difference is applied to the input coil, and the output coil is connected through a diode and a capacitor. Explain how applying potential difference across the input coil causes capacitor to charge. This is a typical questions in your paper relating electromagnetic induction. So the simple idea is you have a alternating magnetic field due to some reason. Alternating magnetic field linked with the second coil, and the flux of the second coil is changing, so EMF is induced in the second coil. This is electromagnetic induction. In this case, you have alternating potential difference in the coil number 1, and this coil number 1 is producing a magnetic field. This is just an example I am sketching. This is not a correct diagram, but some shape of magnetic field you can think, and this magnetic field is linked with the coil number 2, and this magnetic field is alternating. So alternating magnetic field linked with the second coil. So second coil flux is changing. That means in the second coil there is EMF induced due to change in flux, and this EMF causing current, alternating current. But there is a diode connecting. So diode convert this direct current into, this alternating current into direct current, and this direct current goes to the capacitor, and capacitor is completing the circuit. So the current is used to charge the capacitor. You can write this answer in this way, or you can manipulate, you can rephrase in your own words. But idea is magnetic flux of one coil, alternating magnetic field of one coil linked with the second, causing induced EMF in the second coil. Question number 2 is part 2 of that question. The graph shows how the magnetic flux density B in the iron core varies with time. This is magnetic field, Tesla, and time in second. Show that maximum potential difference across the output coil is about 600 volt. Number of turn on the coil 1700. Cross-sectional area is given. So you need to find output voltage. That means this is basically induced EMF that you need to find. According to Faraday, EMF is d phi by dt, and this phi is flux linkage, NBA. So you can say that E is equal to d NBA upon dt. So this N, number of turn, and A is area. These two are constant, so you can take this out. N A from this differential dB by dt. Clearly, if you see dB by dt, this is rate of change of magnetic field. So you need to find dB by dt, and this dB by dt is nothing but the gradient of the graph. Gradient. So if you have a gradient, you can multiply with area and N, you can find EMF. But where to find the gradient? Remember, we need to find maximum potential difference. So we need to find maximum gradient, the position where we have maximum gradient. And maximum gradient can be here or here, which is negative, but it's also fine, or here or here. You need to choose any point so that you can find the gradient. So you need to draw tangent line on these points, any one of these points. I would choose this so that I can have proper values up and down, and then I can find the gradient. So I am let me draw the tangent line. So that's how you can draw a tangent line, and you choose the 2 points. So let's choose this point here and this point. So coordinate of this point above is 5.6 into 10 to the power minus 5, comma 6.0 10 to the power minus 3. This is the coordinate of this point, and the lower point is 4.6 10 to the power minus 5, comma minus 4 10 to the power minus 3. These are the coordinates of these 2 points. Let's find the gradient. So dB by dt, which is gradient. So dB by dt is y2 minus y1. So 6 minus minus 4 into 10 to the power minus 3 divided by 5.6 minus 4.6 10 to the power minus 5. So clearly it is 10 and 10 to the power 2, which is 1000 Tesla second inverse. This is dB by dt. So EMF would be 1000 into 1700 into 3.5, 10 to the power minus 4. So EMF would be equal to 595 volt, which is about 600 volt. If you choose this point and draw appropriate, so you can have negative value. So you ignore negative value and then you can have your maximum EMF. The student tested the capacitor by charging it until the potential difference across the capacitor was 600 volt and recording PD as it was discharged through a resistor of resistor. So this is V and this is R. So decay curve is given. Determine where the mechanical or electrical mousetrap stores most energy. So we need to find, in fact, energy stored in electronic mousetrap, and then we compare with that. So mechanical, remember, is storing 0.5 joule energy, 0.47 approximately, and we need to find electric energy in electric mousetrap. So electric mousetrap contains capacitor. In fact, energy is stored in the capacitor. So if you see energy stored in the capacitor, E equal to half of CV square. Voltage is given, but capacitance is not given. Even we have other formulas of charge. Charge is also not given, but we can find capacitance because of the decay curve is given. So the idea is we can use half-life formula. T half is equal to RC ln2. So we can find this capacitance, and this capacitance can be used to find the energy to compare. So first we find the half-life. Half-life is the time in which 50% voltage is decreased. So 600, 300, draw the straight line with the help of a ruler and you will find that point. And this point is this, which is 0 and 1. So 0.2, 0.1, so 3.1. So T half is 3.1 second. Now you can use this formula to find capacitance. So capacitance is T half divided by R ln 2. T half is 3.1 divided by 3000 ln 2. So C is equal to 1.49 10 to the power minus 3 farad. So energy stored is half of 1.49 10 to the power minus 3 into V square, 600 square. So energy is 268.34 joule. Of course it is greater than 0.47 joule. So electronic micros, you need to write this statement, please. Don't forget a statement of comparison that electronic mousetrap is storing more energy compared to mechanical mousetrap. Question number 16. An object travels with the speed v around a circular path or it should be off radius r. The diagram shows 2 points A and B on the path. So we have a point A and B, circular motion, radius r. The acceleration of the object is A. Derive this expression A equal to V square over R. You should include a vector diagram. First of all, don't confuse with this R. This is, I guess, in my opinion, this is misprint. This R is just radius. It should be R. Or you can say this should be capital R. So same thing. Second, remember this is uniform circular motion. That means speed is same. Speed is same. Speed is constant. But velocity, which is a vector quantity, is not same. It is changing. Velocity is changing due to change in direction, because direction is changing. Clearly you can say at point A you have a direction as per diagram. You can say this is east, and at B the direction is between east and south. So direction is changing, so velocity is changing. and due to change in direction of the velocity we have acceleration. So basically we need to draw a vector diagram of velocity change. So in this diagram, let me erase. So this V is showing the speed, not the velocity, because these are showing the magnitude, size of the arrow, length of the arrow. In fact, if you want to mention the velocity vector, you will have to use symbol VA, velocity at A, and VB, velocity at B. And these two are different because directions are different. So if you need to draw the diagram of vector VA and vector VB with reference to A, how VA is changing with reference to A. So this is the diagram for these two vectors changing the direction. So this is vector VA, and from the same position here A, this is the A, and the new position of this velocity vector is this is VB. That's how the velocity direction is changing. Now if you join these two head of the vector, this is the change in direction, delta V. So we have a triangle A, and you can give, you can name these two vertices of your choice. I'm giving APQ. This is a triangle APQ. Secondly, we join the point A and B with each other. So we have another triangle CAB, and this triangle, this length I'm calling delta S. So in fact we have a two triangle CAB and APQ. There is one thing, that the velocity vector VA is right angle at the radius. This angle is 90 degree all the time. So when vector VA becomes vector VB, it remains at 90 degree. And this property is because of this property, or because of this relation, we can say that the angle between these two radii, R and R, this angle is theta. If given, then between these two, these angle must be same. This is also theta. So angle between VA and VB must be same as angle between these two R's, these two radii, theta. So you need to draw this vector triangle. That's what they are talking about. So this is the vector triangle. Now, once you finish this vector triangle, now you can start your working. First of all, what are we going to do? We are going to consider the time interval. Remember, as per diagram, we assume that the particle is taking delta t time. Delta t is a time interval, and this time interval can be large, can be 1 second, 1.5 or 0.5 or 0.1. It is a time interval. So what if you make this time interval very small? If, that's what you need to start your working. If delta t is very small, very, very, very small, that means the point B will be quite close to A. That means I cannot exactly draw, but I tried. If you see this is OA position, as per this is not OA, sorry, this is CA position, and this is CB. But delta t is small, so CB is quite close to each other, something like this, and even closer than this. In this small interval of time, this angle will be very, very small, and this angle is called delta theta. So theta, which is that angle, now will be very small, very small. Say delta theta. So now you can consider this angle is delta theta. This is triangle CAB. Similarly, these two vector will be quite close, so you don't need to draw these two, this one you don't need to draw, but I'm explaining, that's why I'm doing these two vector VA VB will also be very close to each other. This is VA and this is VB, something like this, and that will be your delta V, and this is angle delta theta. So whatever situation is, in both cases this angle will be same. Now triangle CAB or this small triangle CAB and triangle APQ are similar triangle, similar. And if you recall the concept of similar triangles, similar figures in mathematics, ratio between their sides must be same. So you can say that if you do delta S divided by R, this delta S divided by R, or this delta S divided by R would be same as if you do delta V divided by V, this delta V divided by V, magnitude of the velocity. So this is the ratio between the sides of the triangle. Now delta S is the arc length. S is equal to r theta, if you recall. It is very small but can be considered as the arc length. So delta S can be written as r delta theta, r delta V by V. So r gets cancelled, and then delta theta would be equal to delta V upon V. Now you're dividing by T, dividing by delta T, the time interval. So delta theta divided by delta T is equal to delta V divided by V delta T. We divide equation both sides by delta T. Delta theta upon delta T, it becomes delta W, angular velocity, and this delta V upon delta T, this becomes acceleration. So 1 upon V into delta V upon delta T, it is acceleration. So acceleration is equal to V delta omega, and this delta omega is angular velocity. So V equal to r omega. So A equal to V, and this delta W can be written as V upon R. Finally, A is equal to V square over R. V and V square. So that's how you can derive. Remember, this derivation is not given in your textbook, but there are many other methods to derive this formula. One is already given in your textbook, in which we use sine and cos component, and this is another method in which we use vector diagram. I have done this derivation with the detailed step. Not mandatory to do all the steps if you are good in mathematics. So you can skip some steps if you wish. Like you can skip this step, you can skip this step, something like that. It's your choice. Part B. The photograph shows a toy with a small aeroplane suspended from a canopy by wires. As the platform rotates, the aeroplane rises and follow a circular path. So you see the second diagram. At a particular speed, the aeroplane follow a circular path of 10.8 centimeter. This is diameter. The wires make an angle of 90 degree to the vertical. Complete the free body diagram for one of the airplane. So you have two choices as per diagram. You can consider this airplane. If you consider this, then tension will be acting in this direction and weight will be acting in this direction. If you consider this airplane, tension will be acting in this direction, weight acting in this direction. So these are free body diagram. So you can choose any one of the position. So I say that this is the tension acting, T, and this is the weight acting. This is the free body diagram. Remember the direction, and this 19 degree is in fact angle from the vertical. So this 19 degrees here. show that at this speed, the time for an aeroplane to make 4 complete rotation is 3 seconds. Mass is given. So we need to find time for 4 oscillation. So the idea is we are going to find first for time for 1 oscillation. And then multiply by 4, we have t. And this t we can find from omega is equal to 2 pi by t. But we do not have omega. This omega we can find from centripetal force F equal to m r omega square. And that's what we need to do. We need to figure out the centripetal force. How to do this? So we need to look at the diagram, free body diagram, and we need to see the forces acting, and then we're going to find the centripetal force, then omega, then t. So if you see the situation free body diagram, so we can say that this is the plane, and this was the t that we drew, and the weight. Clearly this t is making angle of 19 degree here with the vertical 19 degree, and this t has 2 components. One is a vertical component acting in this direction, and this vertical component is basically adjacent. So t cos theta. And we have a horizontal component of t in this direction, t sin theta. And this t sin theta is basically centripetal force, Fc. So we know that t cos theta is equal to mg, w, the vertical forces, this is w, mg. T cos theta is balancing the weight, vertical weight, and then t sin theta is a centripetal force, Fc, mr omega square. And now clearly we have 2 equations, sine and cos involved. We can easily find whatever we need to do. So t can be cancelled if we divide these 2 equations. So we are dividing t sin theta is divided by t cos theta, left hand divided by left hand, and right hand divided by right hand. So mr omega square divided by mg. T cancel, cancel, sin theta over cos theta. This is tangent theta is equal to r omega square upon g. So omega would be equal to root of g tangent theta divided by r. Now g is 9.81, tangent of 19 divided by r, and r is given, let me see, 10.8. This is the diameter, this much. So the radius is this. So 5.4 centimeter need to be converted into meter. So 0.054 root. This is omega. And omega would be equal to 7.91 radian second inverse. So t is equal to 2 pi over omega, and omega is 7.91. So t would be equal to 0.794 second. So total time for 4 revolution, 4 times of t. T is equal to 3.2 second. Student A suggests that if the radius of the canopy was increased and rotated at the same angular velocity as before, the wires supporting the aeroplane could be vertical. Student B suggests that the wire would be at an angle of greater than 90 degree to the vertical. Explain whether either of these students is correct. Okay. Now this is the situation, this is the diagram, and suggestion is if the radius is increased, canopy, this is the canopy, this is the radius. If this radius is increased, student A is saying that the wire should be vertical. Now imagine, suppose if the wire is vertical, that means tension will be acting vertically exactly upward, and weight is acting downward. That means weight is completely balanced by the tension. Then there will be no horizontal component of the tension. So there is no horizontal component of T. If there is no horizontal component, that means there is no centripetal force, which is not possible. For every circular motion, we need a centripetal force. And in this case, because this is center, so some horizontal force should be acting towards the center. But T is because as per suggestion, rope is vertical, so we have vertical tension. That means no horizontal component, no centripetal force. That means student A's suggestion is incorrect. It is not possible that the rope remains vertical. Now student B is suggesting there would be angle greater than 90 degree. So if R is increased, we know that F is equal to mr omega square. Speed is same angular velocity, mass is same, so centripetal force depending upon the radius. So if radius is increasing, that means centripetal force is increasing. So we know that the centripetal force in this case is T sine theta. This is the centripetal force. So F is nothing, centripetal force is T sine theta. And clearly, if radius is increased, F is increasing, F depending upon the theta. So theta must be increased. So student B suggestion is correct. If radius is increased, then the angle will be more than 19 degree. So this is how you can incorporate all these comments, all this point. Remember, you can use this or you can reframe in your own words. Question 17. Cloud chamber are used to observe the paths of particles. The photograph shows a pair of tracks made by alpha particles emitted when an atom of radon decays in a cloud chamber. So we have two tracks, track 1, track 2. These are alpha particles. The radon atom do not leave track. State the reason for this. Remember, when we talk about tracks of particle in a magnetic field, we have only track if the particles are charged. If some particles are uncharged or no charge or neutral, they do not leave a track. So radon is not leaving any track. That means radon is uncharged, or there's no charge on radon atom. Radon decays by emitting an alpha particle producing a polonium nucleus. The polonium then decay almost immediately by emitting another alpha particles producing lead. Complete the nuclear equation for this sequence of decay. So we have radon, lead and alpha. Clearly, if you read the statement, we have two alpha particle emitted, radon decaying polonium emitting alpha, first alpha, and then immediately decaying into lead and emitting second alpha. So we have two alpha particles. So there is two. And alpha number, alpha charge is 2, and mass number is 4, nucleon number is 4. So of course we have, you can do 2 times 2 is 4, 82 plus 4 is 86, and 2 times 4 is 8, so 220 minus 8 is 212. That's how you can complete this equation. The radon atom was stationary. Radon atom was stationary before the first alpha emission. The angle between the two alpha track is 60. Sketch a vector diagram to show the momentum of the two alpha particles and the lead ion. These are the alpha particles shown. Remember, this angle is 60 degree. So you need to draw a vector diagram showing the momentum of all the three particles. Alpha 1, this is alpha 1, alpha 2, and then we need to sketch the momentum of the lead ion. Remember, all these three, the 2 alpha and the lead, are final product of radon, and radon was initially stationary, so initial momentum was 0. That means final momentum must be 0. So the sum of the momentum vector in the final diagram must be 0. So let's draw the diagram. First we draw the vector of momentum of alpha 1. This is alpha 1, and then you need to measure the angle of 60 degree. Do not forget the angle of 60 degree. Without that 60 degree, your diagram will be incorrect. So accurately measure this 60 degree angle, and then you can draw the second diagram. This is alpha 2, and we need to add these together by head and tail rule. So this is alpha 2. This is actually the diagram that you need to draw, not the first one. It was just, you know, for your understanding. So alpha 1 momentum is adding into alpha 2, and then adding the momentum of lead become final momentum 0. It is only possible if you join head of the last. If you join head of the last, tail of the first, showing there is no resultant. So momentum will be 0. That's how you can show the momentum vector diagram for all the 3 particles. This angle here must be 60 degree in your diagram. Please don't forget to mention this angle or measure this angle accurately, because this is a vector diagram. Okay. Determine the magnitude of the velocity of lead ions. So we need to use law of conservation of momentum. That's why this is the diagram that we drew in the last question. So the idea is, this is the vector momentum of lead. This is alpha 1 momentum vector, and this is alpha 2. Now we know that we have a vertical momentum of alpha 1. This is fine, but we can have a component of alpha 2. Now resolve momentum of alpha 2 into its component. So we have a vertical component down for alpha 2, and then this is downward momentum, and this is horizontal momentum, like this. So let's call the momentum of this particle P1 alpha 1, and this is P2 momentum of alpha particle 2, but this is not just P2, this is P2V, and this is P2H. Now overall situation is, if you see the vector diagram starting from this position all over coming down, I cannot draw straight, but if you see, if this is a straight line, this is the vertical momentum of lead particle PV, and this is the horizontal momentum of the lead PH. So if you add P1 and P2V together, P1 and P2V together, you have PV, and then if you find P2H, it will be equal to PH, and we can use Pythagoras theorem for PV and PH to find this PV, and that's the idea. So first I'm going to add P1 and P2V to find PV. Remember, this angle is 60 degree. So PV is equal to momentum of the first particle, which is P1 P2V. So P1 is m V1 plus m V2 cos of 60. This is P2V, this is P1. So let's put the number. M is the mass of alpha particle, and alpha particle consists of 4 nucleon. So 4 times of 1.66 10 to the power minus 27. Mass of alpha particle is given. If it is not given, you can find alpha particle mass like this. This is mass of alpha particle into velocity of alpha particle V1. So this is your V1. So 1.74 into 10 to the power 7 plus mass of second alpha, which is same, 4 into 1.66 10 to the power minus 27. V2 is this 1.81 into 10 to the power 7 cos of 60. You solve this, you have a PV. This is the total vertical momentum. So you use your calculator, 1.76 10 to the power minus 19 Newton second. Now let's talk about P2H, horizontal momentum of alpha 2. So P2H is m V2 sine theta 2. Sine 60. So again 4 times of 1.66 10 to the power minus 27. V2 is 1.81 10 to the power 7 sine of 60. So the answer will be 1.041 or 1.04 into 10 to the power minus 19 Newton second. This is P2H. So but P2H is the horizontal momentum of lead. So you can say that momentum of lead PB, lead of PB would be PV square plus P2H square root. So this is 1.76 10 to the power minus 19 square plus, must be in bracket, okay, P2H 1.04 into 10 to the power minus 19 square and then root. So momentum of PB is 2.04 into 10 to the power minus 19 Newton second. And this momentum is mass of the lead, velocity of the lead, PB, 2.04 10 to the power minus 19. So velocity of the lead will be this divided by the mass. So 2.04 divided by mass, mass is given PB. So you divide 2.04 10 to the power minus 9 divided by that mass. So velocity will be 5.80 ms minus 1. This is the velocity of the lead. The photograph shows another pair of tracks following radon decay. Deduce which tracks is for the first alpha particle emitted. Either this or this. Now if you closely look at the diagram, we have a gap between these two tracks initially. And we have already said that radon was a neutral particle. So in the beginning, when alpha particle is emitted, if this is some neutral particle and this particle emits a charged particle in any direction, I'm assuming this particle is decaying or emitting another particle in this direction. This is a charge. So we see the track. This neutral particle will recoil, depending on the mass, will recoil backward. So this whole nucleus will recoil backward in order to conserve the momentum. So we see the gap here. That means when alpha particle was emitted, the radon recoils and goes in opposite direction, and then immediately emits second alpha. So that means there was a radon and alpha particle emitted, and then it recoils backward, meaning downward, and comes here, and then immediately second alpha particle. So we see the second track. So looking at these conditions, because of the gap and recoil condition, it is said that the right side track must be the track of first alpha particle. Question 18. The photograph shows a hospital radiotherapy machine that contains a linear accelerator, LINAC. The LINAC accelerates electrons to very high speeds for use in treating cancer. The electrons used in LINAC are produced by a filament in an electron gun as shown in the diagram. This is electron gun, anode and high potential difference. The name and describe the process in which electrons are produced by filaments. 2 marks question. So electrons are emitted by heating the element due to high potential difference. So high potential difference is applied and the filaments get heated, and then electron inside the filament lamp gains energy, and due to high energy electron comes out, and this whole process is called thermionic emission. Emission of electron due to heat is called thermionic emission. So the process name is thermionic emission, in which electron gains energy after heating and then comes out from the metal surface. The diagram shows part of a simplified LINAC. An electron enters the LINAC from the electron gun with the speed of this. The electron passes through 60 drift tubes before emerging from the other end. Calculate energy of the electron as it emerges. So basically electron entering in the first drift tube with this velocity, that means electron already has some kinetic energy, EK1. And then when electron enters in the first drift tube, then potential difference are applied. Then electron further gain energy, and then it keeps gaining energy and keeps gaining energy and keeps gaining energy until it comes out from the last tube, whatever the last tube is. So then electron is gaining additional energy within the tube, EK2. So the total energy will be EK1 plus EK2. So we need to find these two energy, and we add together to find the total energy or final energy coming out. So let's find the initial energy. We have given velocity. So EK1 is half mv square because velocity is given. So half of a mass of electron given in your data sheet, 9.11 10 to the power minus 31 into v square, 2.5 into 10 to the power 6. So EK1 would be equal to 2.8 10 to the power minus 18. Let's talk about EK2. EK2 is due to potential difference of 80 kilovolt between adjacent drift tube. There are 60 tubes. So the idea of EK2 is V into Q, because as per definition, voltage is energy divided by charge, energy per unit charge. So energy is voltage multiplied by the charge. In this case, the charge is electron and V is the voltage, but we do not have only two positions. We have 60 drift tubes. But remember, if you have a 60 drift tubes, so we don't need to multiply by 60 because we have a 59 gaps. Like in this diagram, how many drift tube do you see? 1, 2, 3, 4. An electron will come out. But how many gaps? 1, 2, and 3. So 4 tubes, but 3 gaps of potential difference. That means EK2 would be equal to voltage, which is we have a 60 tube, so 59 gaps. The total voltage will be 80 kilo 10 to the power 3, and then into charge, and we have electron, so 1.6 10 to the power minus 19 electron charge. So energy would be equal to 7.552 into 10 to the power minus 18 minus 13 joule. So total energy, if you add them together, EK would be equal to sum of these two, so 7.552 into 10 to the power minus 13 joule, which is rounded off to 7.552 into 10 to the power minus 13 joule. This is the total energy. For very high energy electrons, successive drift tubes have the same length. Explain why. Very high energy. Very high energy mean generally we say that electrons have reached a speed close to speed of light. So electrons are moving close to speed of light, and at that speed cannot increase further than that, so speed is not increasing. So speed is same, that means time, they are taking equal amount of time in each tube, and according to S is equal to UT, speed is same, time is same, so distance traveled by the electron in each tube is same, and this distance is in fact equal to the length of the tube. So that's why all the length of the tubes are same at very high speed. Linacs used for radiotherapy operates by means of standing waves formed within the linac. Explain how standing waves are produced. So standing waves are produced, two waves moving in opposite direction. One wave is coming from left, the other wave is coming from right. Two waves moving in opposite direction, they superpose, they interfere. Due to interference we have a constructive interference and destructive interference, and due to overlapping then we have a pattern of nodes and antinodes. Nodes is due to destructive interference, and antinodes is due to destructive interference. Electrons emerging from a standing wave linac must be directed towards the patient magnet. Magnets are used to rotate the path of the electron beam through 270 degree. Determine the magnetic flux density required to rotate the beam through 270 degree, and the energy of the electron 2.5 kilo electron volt, radius of the curvature of the path 61 millimeter. We need to find magnetic flux density B. So we are giving charge, we are giving radius, so we have equation that the radius of the curvature is R is equal to mv by bq, or bq or be. So because we have electron, that's why q, e, we need to find b. B is equal to mv upon re. That's mean we need to find the velocity. So energy is given, electron energy is given, we can find the velocity. So we can say that half mv square is equal to v into e. So velocity would be equal to 2ve divided by m. This is the velocity. And if you put all the number, so we have a 2, V is the voltage, and voltage is 2.5 into 10 to the power 3 electron volt, and 1.6 10 to the power minus 19, this is joule, and divided by mass. Mass of electron is 9.11 10 to the power minus 31 root. So velocity will be equal to 2.96 10 to the power 7 meter second inverse. So B would be equal to mass 9.11 10 to the power minus 31 into velocity 2.96 10 to the power 7. Mass into velocity divided by R. R is the radius, 61 millimeter. So 0 divided by 1000 millimeter into meters, so 0.061 into electron charge 1.6 into 10 to the power minus 19. So magnetic flux density will be 2.76 into 10 to the power minus 3, or 2.8 into 10 to the power minus 3 Tesla. I hope you understand this paper. If you have any problem, let me know in the comment section. I will try to clear your doubts as soon as possible. Have a nice time.